Hey folks, this is Sanjeev here from vNext Labs and World Robotics League. And today I am going to talk a little bit about the FLL 2020 season, the one that's upcoming. And the name of this season is Replay. I'm going to talk a little bit about the game board analysis, the strategy, and some of the predictions that we have. So without further ado, let's go into the source of this season. So originally when we looked at this, we looked at the board from the actual teaser. So this just came out a week or so ahead, and we looked at the board and we had some ideas, but then the quality of the board is kind of grainy and it's very hard to make out the parts. So we researched on the internet and we found some other website that was actually had a much clearer picture of the board. In general, first sometimes collaborates with certain teams and so on to vet the ideas out and see how the board will actually work out in real life. So likely this is one of the teams that has had a chance to play with the board a little bit ahead as a test. So anyway, so for our purposes, this works quite well. So if we look at the elements, like we have gone by the Lego elements on the board, and sometimes we also have access to the bigger blow-ups of these boards. Sorry, these elements, Lego elements. So from the left hand side, we see we have marked them going from left to right. 1, 2, 3, 4, 5 over here. This one looks kind of interesting actually. Number 4 and number 5 both look interesting because they are using the new spike prime wheels, the smaller wheels at least. And the number 6 looks like it's the bigger spike prime wheel. Number 7, which looks like a bit of a bar raised quite up high from the floor. Number 8, number 9 here. Number 10, we couldn't find any better pictures of this than what is available on the board. And number 11, which looks kind of interesting. So without any further ado, let's look at the various elements. So let's look at number 1. And the number 1 is essentially, it looks like a basketball hoop. So if we look over here, there are 2 rails. Like we see these rails, essentially we call them rails because they are completely in line. There is no element that's extruding out of these. And this looks like a place where you're going to dunk a ball. In fact, there is a ball drawn over here on the board giving you an indication. And this seems like it will smoothly slide up on this one. There seems to be some element up here that will actually hang on. It's kind of hard to make out. So we are assuming that once this goes up, it's going to get lashed and it will stay up there. So in our mind, this is mission number 1. Move it up and have it hang up there. If you look at the, to make sense of the next challenge, the challenge number 2, let's look at the back-to-back board configuration of the FLL tables. In general, in real life, when you're competing, it doesn't really matter. Like, even though it looks nice to have 2 boards next to each other, in reality, the teams don't interact in any whichever way except for some very specifically designed challenges. And we have marked these 2 challenges. The same element repeats on here and then in the second place over here. And you can see that they are exactly symmetrical. So if we look at it in detail, one of the pictures that we found, you can see, although it seems like they are this element over here, this is the challenge 2, it's actually connected to the basketball hoop. It is not. It's very hard to make out, but actually there is a piece over here, this one, which actually gives a quite bit of a large footing, and that is allowing this structure to stand up. And what you're supposed to do is there are 2 cubes over here. There are multiple cubes over here. You see there's one red cube here and one blue cube here. What you're supposed to do is push, somehow slide these things down. There are 2 chutes over here, one here and one here. These are completely flat and smooth chutes made of Lego plates, and you can just somehow make them slide. There is a bit of we found a screenshot and we noticed that there is a spike prime robot showing, like, coming from under here and pushing it. So it does seem like, you see this angular beam over here, you can actually push this up to simply actuate it and have these things slide down. So likely, you are going to have to push this one up, or you can engage with another way and slide it over. In general, we are not a big fan of challenges that are actually on the boundary of 2, because quite often in the spirit of cooperation and all, you are supposed to solve this challenge for yourself and for the other team. And although by itself it's a nice thing to have, a nice thing to learn, when you're competing, we would rather not give any points to our opponents. Number 3. So number 3 is, again, this is the same area, the area where the previous challenge is supposed to drop the elements. You notice there are like 2 separate, I would say, a partial hexagons or octagons. So there's a smaller element, there's a larger one. I'm assuming if you drop something in the smaller one, you're going to get more points, versus if you're going to drop it in the larger one, you're going to get less points. And over here, we see this is actually a Lego turntable element. It is somewhat rare. It's found in some of the larger techniques, cranes and some such, where you want to move the base. and there's a large big piece over here, and there's a cube over here. So our assumption is that you are supposed to actually turn this one, so this slide actually points inside this section, and then hit it somehow, this cube, so it actually slides in. So that is our prediction on this one. There is an element, we haven't talked about this element later, this element or at least we haven't pointed out in the original board, but we'll talk about this one at a later point of time. So moving forward, this one is a much clearer picture. This seems like the last year's challenge, or the space challenge that we had, and this seems pretty straightforward. These wheels are fairly heavy, right? So now you have a seesaw-like mechanism, and there's a place where we can grab on and push it. In fact, if you look at these circles are actually not simply, there is a bit of an extension over here. There's a bit of a rod that actually connects the rest of the structure to these wheels. So you are supposed to either grab on or push it super hard so that this thing lifts. At least that's our prediction. Moving on to the next challenge, number 5. This is yet another, we love the fact that they have actually provided a bunch of spike prime wheels in here. We love these new spike prime wheels. They are super sturdy, and they work quite well in the robot movement. So when the challenge is over, you're going to have a bunch of pieces available to you. Anyway, so coming back over here, there's a rope, Lego rope, that actually comes in here. You can see the pulley over here, and this rope actually goes over here, comes down, and is attached somehow to these guys. I guess these guys are attached to each other via an axle. A little blue axle is here. When you pull this one, the wheels will actually climb on this one. So again, our assumption is that you're going to likely have to push this one outside so that these wheels actually reach up. Challenge number 6. So looking at the video, they show a lady that is actually pushing up a huge tire. This is usually considered as a feat of strength, to push up a huge tire straight and then turn it over. So our assumption is that you will have to take this large wheel, this is a rubber wheel, on top of this other wheel. You are likely going to get some points if you just are simply able to turn it and land it somewhere within the circle, but if you land it on top of this other wheel, you're likely going to have a lot more points. Number 7. This one is a bit of a interesting structure. In the recent FLL challenges, there have been this element where you have to go and latch your robot and climb onto something. It is possible that this is the same thing, but we couldn't find a better picture of this one, but we see there is an element over here. It's possible that you may have to slide this left and right, or it's possible that you may have to hang on to it, or it's possible that if you move on this road from under the robot, you get higher number of points. From the way we looked at it from various angles, and it seems like this is a couple of, I would say about 8 to 12 inches high, probably not 12, but at least 8, because the beams that are connected here are likely 13 or 15 beams, and then another 15 beam on top of that. So your robot may be able to move under it, but in general, we would not want you to limit your robot because of this structure. There are a lot of points that can be had elsewhere. So if you want to attack this one, then be careful that you may lose points elsewhere. Looking at the next one, number 8. So number 8, this is pretty straightforward. This is the slide that kids have. You can see there is a frame that has been made with axles and the axle connectors, and there's a little minifigure that's actually attached to the top. So if somebody pushes this frame over here, it's going to slide down all the way and out. And then there's another kid that's sitting on the frame and over here. So one, you have to slide this little kid down, and then push this kid up and slide them down. That is what we believe this challenge is. Looking at the next one, this one was a bit of a quandary because we couldn't find any better pictures. But if you look at this one over here and this one over here, it feels like this structure, or rather this frame over here, the frame at the top, right? This frame over here, this simply sitting on top, because this connector actually has one piece here, like there are one hole here, and there's an axle hole here. So unless you attach something on the other side, like a bit of a axle connector or a bush, which we don't see over here, you likely have to lift this and place it somewhere over here, possibly. It is attached at the bottom with the 3M gluing mechanism, the gluing Velcro kind of pieces. So you cannot likely move this one, but this one you may just have to lift this structure and place it somewhere else in the same location. Now, looking at the number 10 and number 11, we could not find, number 10 and number 11. So number 10 is over here and number 11 is over here. We couldn't find any significantly better pictures, but if you zoom in on this one, it just seems like a long rail on which you likely have to slide this one. We actually really are not sure. This is completely hypothetical because we cannot see enough detail at all in this one. But it's possible that you likely have to move something, slide something from here to there. Number 11. Number 11 looks like an exercise equipment. Sometimes you have exercise equipment that you have to actually turn over. So this looks like an L beam, and if you push this one over here, this one will likely follow suit, and some sort of mechanism will actuate. So again, pushing this one over here and likely turning it over. There are a few more things. For example, remember we talked about this one. This structure is close to the border, the shared border between the two tables. Looks like it's actually a music player. Because I mean, if you look at some of the blow-ups in the challenge or in the teaser, then you can see there's a music and so on and so forth. So this is likely a music player. Even the central portion looks like an old iPod. So our assumption is this is sitting all by itself. So more likely than not, this is considered a lost element on the field. So you likely have to move it back to the base. So that's our assumption on this one. The next one we saw somewhere else. Some people were commenting saying likely you have to bring this this skateboard back to the base or someplace, but we don't think so. We think this is simply a pictorial artifacts, and the reason for this is if we look at this over here, right? Notice this is this is the actual skateboard, and this is the picture of the skateboard. This actually looks like a print, not a real Lego mechanism or a real Lego element. So these two simply look like they are just pictures. Going back, see, this thing looks like a print. This thing looks like a print. This thing looks like, because there's no way this skateboard can actually stand upright next to a picture without having a flat base, and there is no flat base on this thing, not much at least. So that's at least that's our opinion. Now looking at the strategy portion of this one, in general, FLL strategy is like, pick a area and solve everything within that. So we claim, or at least we think, that this is how you should ideally divide up your entire gameplay. Section 1 here, that takes care of all the elements closer to the base. Like this is your base, right? And so you are going to have to take care of this one, this one, this one, and this one. We would shy away from this one, but this one seems like straightforward. This one actually seems like a bit straightforward, and because I think this is the slide, this is the basketball hoop, and this one we were not certain, but probably just picking and putting it next to like picking something from here and just placing it over here. So these two are close enough that you could probably attack them without having too much of sensing and all that, right? Because this is not very much of a distance, either here or here or here. Now, most of the points are actually going to be concentrated in zone 2 and zone 3. So let's look at zone 3 because it's closer to you. So there are two ways of doing this one. It's not clear whether there is any space between this model and this guy over here, the wall over here. If there is some space and it's possible to actually for a structure to move over here, you might just create a large structure like about this big and have your robot push it gently down this path, and then while you are pushing your robot down this path rigidly by having a large structure over here that is a fixed at a fixed distance from the wall, or rather pushing against the wall, or I should say wall following, you can attack this one, this one, this one, and this one without having to move your robot too much. If you can of course try and line follow this line over here, this black line, but just like the past couple of years, Lego has started putting all these colored and shaded areas, which will make it a little bit harder. So there is probably an inch thickness of line, and there's an inch on this side and there's an inch on this side. So either you need to have a very, very finely tuned PID loop that allows you to move very, very carefully along this line, or if you move a little bit out of these things, then your color sensor may get confused. So although you can follow this line, if you can actually have a wall following structure, that would probably work out a lot better for you. You can also do the line following over here, and even though on the face of it seems like these small lines, the vertical lines, you can actually use two color sensors, one to follow this one and the second one to sense these lines. It's possible, especially if you put the color sensor in intensity sensing mode, and you notice the transition from grayish to white to black, and you say, okay, reach 1, reach 2, reach 3. But in general, if your team is not super skilled, we would ask you to, or we would recommend that you avoid that, because color sensor can get confused. Your robot is moving fairly fast. The readings are not actually done that fast. So before you detect this, the transition from gray to white to black, your robot may just get confused and call this like stop here or stop after or somewhere. So follow the line, but use other mechanisms if possible to detect where you are. I don't know, maybe based on odometry, because this is a fairly straight segment, so you can combine the rotation encoder or the encoder along with the color sensor to detect how far you have gone. Attack this one, and this one simultaneously, and then come back. In general, our recommendation is not to attempt not to bring the robot back to base more than a couple of times, 3 or 4 times. Have a maximum of 3 or 4 missions, and this nicely fits in there. Like, one mission outing over here, finish whatever you can, one mission outing here, and one mission outing here, and that's pretty much all we would recommend at this point of time. Based on the information available, this is all we can come up with. Let us know in comments what do you think about our video, and also please subscribe. Thank you, and see you next time around.